beautiful people, and welcome. In this video, we're going to be continuing our discussion about angles. This is going to be an examples video. If you're in my class, this is going to be very similar to classwork number 17, all things angles. If you're not in my class, that's fine. You're going to be able to see all of these worked out. If you haven't already watched part 1 of the lecture for angles, go ahead and do so you kind of have an idea what we're talking about. All right, let's go ahead and jump in. Convert each degree measured to radians. So this is a degree. We want radians. So remember our conversion rate. Whatever you want goes on top. So we're going to multiply this by pi over 180. We know that half of a circle is 180 degrees, or half of a revelation, or half of rotation is pi, or 180 degrees. So what are we doing? We're going to multiply and get this taken care of. So I'm using my calculator. 195 times pi. And I want the exact answer. So what I'm going to do is I'm going to simplify the fraction first, and then I'm just going to add pi to it, because I don't want to use pi because my calculator is going to go for a rounded answer versus a exact. So 195 divided by 5, that is 39. 180 divided by 5, that is 36. And I feel like I can simplify that more. So I'm going to do that. 39 divided by 3, that is 13. Don't forget your negative. And 36 divided by 3, that is 12. So the degree of 195 negative is the same as negative 13 pi over 12 radians. Now, you don't have to write the word radians. If you include pi, it is assumed that it is radians. Like, it has to be radians if it has pi in it. Let's do another one. 435. We are converting that to radians. So I'm going to do radians on top, which is pi on top, 180 on the bottom. Again, my calculator doesn't do exact, or it does, I just don't know how. So I'm going to just simplify it here by dividing by 5 first. So I have 435 divided by 5, that is 87 pi. Keeping my pi, not touching pi. 180 divided by 5, I think I already just did that, as 36. I'm going to divide that one more time. And that gives me 29 pi over 12. Something very similar, you guys didn't see that, is we're going now from the radian to degrees. Because I want degrees as my answer, I'm going to flip the fraction and say I'm going to do 180 over pi. What's really cool is when you're doing this, the pi's cancel out. Multiplication is king, so your pi's will cancel out. You will not have pi in your final answer. And then you can continue. I have 9 fourths times 180. So you can simplify that. 180 divided by 4. Let's see if I can do this here. I'm going to divide out first, and that is 45. So 45 times 9 is 405. Now 405 you cannot leave as 405 because it doesn't have pi in it. Doesn't mean it's radians or degrees. So you have to tell the reader what it is. In this case, it is degrees. So you put a little degree symbol there. Moving on to question number 4. Again, what is our objective? We want degrees, so degrees go on top. Pi goes on the bottom. Your pi's will cancel out if you have, 2 pi's. 180 divided by 3, I like to cross cancel first. And you need this in the form of a fraction. Don't do decimals. Decimals are big no-nos. In this case, it is 420 degrees for this one. Moving on to question number 5. It says, draw an angle with a given measure in standard position. Now, standard position means you have an initial ray. This is your initial ray. And it is counterclockwise. Counterclockwise. The first one is we have 650 degrees. Oh boy. So this is what I'm going to ask you to do. Split it up. We know that one full circle counterclockwise is 360 degrees. If I go 360 degrees, one full rotation, I still have 290 left. So 360 plus 290 degrees, that gives me 650. So I know I have not 2 full rotations, just 1 full rotation. But this one here can also be split up. I know this is 0 or 360 degrees. This one here is 90 degrees. Again, counterclockwise is standard, 270 degrees. So if I'm going full one rotation, I have traveled 360 degrees. I need to travel 290. So what I'm going to do is I'm actually going to split this up as 360 plus, I know this is 270, plus 270. How much more do I need to add in order to get to 290? And that's 20. I'm going to rewrite that one more time down here. This is what I'm thinking. 650 is one full rotation. I can then travel 270 degrees, and then I can travel 20 degrees. This gives me an idea of where my terminal ray needs to be. So that means here is counterclockwise. Oh, I didn't go counterclockwise. No, yes, I did. Counterclockwise, opposite direction. I'm going 260 degrees, 270 degrees, and then I'm going to go 20 more, which is like about here-ish. We're guesstimating, so it's pretty close to 200 and, it's really close to 270. We're just 20 over that. Let's do this one, negative 425. This means we're going opposite direction or clockwise. That means this is 90, this is 180, this is 270, this is 360. We're going to do exactly the same thing. Don't let the negative fool you. Fool you negative is just, that means we're going opposite direction. We're going clockwise. We're going to split this up just like we did before. One full rotation is 360. If I go another full rotation, I'm going to go over, so I don't want to do that. 425 minus 360, that is 65. So that means I need, all of this is negative because we're going clockwise. So I need 65 degrees over one full rotation. I'm going clockwise, so I'm going this way. One full rotation, that's fine, one full rotation. And then I have 65. So 65 is a little bit more than halfway, so we're about here. Moving on to question number 7, we are now dealing with radians. Now, in my opinion, it's just my opinion, it's a little bit more confusing with radians, but it doesn't have to be. You can convert to degrees if you would like to, but it works the same way. You're going to split this up. I have negative. This negative means I'm just going clockwise. That means this is your 90, this is your 180, this is your 270 degrees. In this case, since we are dealing with radians, you want to convert that to radians. So this is pi, this is pi halves, this is 3 pi halves, and this is 2 pi or 0. Then you want to figure out how many rotations do you have. We know that 2 pi is one full rotation. That means that if I take 55 pi 18ths, one full rotation, or 2 pi, would have to be 36 pi over 18. Now, why does it have to be 36 pi over 18? Because 36 divided by 18 is 2, and so this is equal to 2 pi. And 2 pi, what do we know about 2 pi? 2 pi is one full rotation. I have 36 as my numerator. I need 55. So 36 minus 55. So I need 19 more. So that means I need 19 pi 18ths. Well, what do we know about 19 pi 18ths? Well, that's kind of pretty close to just pi, because if I do 18 pi is just pi. 18 divided by pi is just pi. So that means I just have pi 18ths left over. So like a very, very small amount left over. So when we break this up, we can easily see we're going clockwise, so we're going down instead of up. We got one full rotation, so we got 2 pi. We got one more pi, which is half of rotation. And then we have pi over 18, or we have 1/18 pi, which is a very small number. So we're going to go barely up and call it good. I think I went too much up, but that's okay. We're human and humans make mistakes. It should be a little closer down. Let's do this one more time. Here, pi 6. It's a little difficult to do the same thing because we don't have any full rotations. It's pi 6. So here is pi halves. It's not negative, so we're going opposite counterclockwise, right? Here is pi, here is 3 pi halves, and here is 2 pi or 0. So if we have pi halves, half of that is pi fourths. Or we can split this up into thirds. So this is pi sixths, this is pi thirds. Excuse me, we can split it up into sixths, and then we can do that. All right, so then what do we have? We want pi sixths, so it's going to be a very small angle here. All right, let's move on. Question number 9 is asking us to find the measure of each angle. So this is a big one. They're telling you two things. Here they're telling you that this measure is 80. You guys can barely see that, but it says 80 here. But then that's not the angle they're asking you. It's this one here. And how do we know that it's this one? Because it has an arrow. It's pointing towards the terminal ray. So we are going clockwise. So that means our angle is negative. We start at the initial ray, we end at the initial ray once. That means I have 360. I'm starting at the initial ray. I am almost ending at the initial ray, but I'm not. So I don't have another rotation. I almost have another full rotation. So what I have is I have here. So this is my 90. This is my 180. This is my 270. So I have traveled 270. And then I have traveled from 270 to my terminal ray, the distance of 80. So 360 plus 270 plus 80, that means I have traveled the distance, and make sure it's negative because we're going clockwise, a negative 710 degrees. Now, how did I know to use degrees instead of radians? Because this angle measure right here from 270 to my terminal ray is in degrees. So that should be a negative 710 degrees. Moving on to question number 10, same thing, except this time we are going clockwise. Just kidding, we are going counterclockwise, so we have a positive. So our angle is positive. Let's see how many rotations we have. We have one full rotation. So I have 360. I have not quite. So I have 270. Now here's where you need to be careful. Notice that my angle measure does not include this 50. This 50 is outside of my angle measure. So we need to find out what this distance is. Well, the distance between here and here, we know this is 90 degrees. It's 1/4 of a circle. So if this distance is 50, then this distance is what? 5, 6, 7, 8, 9. This distance is 40. So I traveled one full rotation. I traveled 270 degrees, and then I traveled an additional 40. Keep in mind we are counterclockwise, so this is going to be a positive measurement. We know this is in degrees because this is in degrees, so I have 360 plus 270 plus 40, and that gives me positive 670. We know this is positive because it is going counterclockwise. And we need degrees or else we won't know what unit of measure we have. All right, let's moving on to this one. Oh, this one has pi in it, so this means that our answer is going to be in radians. Let's figure out. In radians, we are going counterclockwise, so this is 0 or 2 pi. This means this is pi halves, this is pi, and this is 3 pi halves. What do we have? We have one full rotation. That means I have 2 pi. I have one full rotation. That means I have another 2 pi. And then from here to here, they're telling me that that distance is pi thirds. So what do I have? I have 4 pi plus pi thirds. You can keep it as 4 pi plus 5 pi thirds, or you can convert this into common denominator. So I'm going to choose to do that. I'm going to multiply top and bottom by 3. So it means I have 12 pi plus pi thirds. and that's equal to 13 pi thirds. Again, positive because we're going counterclockwise. Moving on to number 12. Number 12, we are going counterclockwise, so we're going this direction, so it's going to be positive. And again, how many rotations? This is one full rotation, so this is 2 pi. Starting at my initial again, this is almost but not quite. So this here is 270 degrees, or in other words, 3 pi halves. So I'm adding a 3 pi halves. And then I need to figure out what this angle measure is. We know that this little piece is pi 6, so I need to know what this piece is. So this is where you need to go back and think, well, what is 1/4 of a circle in radians? If we know 1 full circle is 2 pi, half of a circle is pi, 1/4 of a circle is pi halves. So that means that this full, kind of drew that a little bit weirdly, but this full angle is pi halves. We know that this section is pi 6, so I need to find out what this one is. So I'm going to subtract and figure this out. So I'm going to use common denominators. So 3 pi 6 minus pi 6, which means I get 2 pi 6, which means I get pi thirds. So that means this little piece right here, this piece is pi thirds. Okay, so we have pi thirds. So we have, what do we have? We have 2 pi plus 3 pi halves plus pi thirds. Common denominators we do not have, so we need to do common denominators. So 2 pi plus, let's do 6. So let's do 6 pi, just kidding, that's going to be a 9. So I'm multiplying top and bottom by 3. This one's going to be multiplying top and bottom by 2. This is 9 pi thirds plus 2 pi 6. This should be a 6, not a third, 6. And then this one, again, we need to multiply by 6. So this is 12, 6. So 9, 10, 11. 11 plus 12, that is 23 pi 6 as my angle measure. Moving on to question number 13, 14, 15, 16. It's asking you to find the reference angle. Reference angle, again, positive, acute, which is less than 90 degrees, and starting at the x-axis, going all the way up to the terminal ray. Okay, but it has to be small and acute. If you wish, you can draw it. It might be easier for you to draw it. You're going to find, in my opinion, find a coterminal angle first before you find a reference angle. Sometimes when you find a coterminal angle, that's going to be your reference angle, but not all the time. So I have 28/9. So I'm going to split this up. Oops, not plus, but I'm going to split this up into rotations and see where my terminal ray is. So I want it within 1 revolution. I want it between 2 pi, or I want it between 360 degrees. So far, it's pretty big, so it's not. 2 pi would be 18 divided by 9, which is 2. So I have 18 pi divided by 9. This right here, that's 2 pi. But I have more than 18. I have 28. I have 10 more. So that means I have 9 pi over 9, and I have one more pi over 9. This right here is pi, so this is what's left over. And what you're going to notice is that a lot of times, whatever's left over, unless it's like super big, still within the 1 revolution, but super big, it ends up being your reference angle. Not always, don't quote me, but we'll see. So then what do we have? Let's draw this out. Counterclockwise, because it's positive, I have 1 full revolution. I have pi, which is half of a revolution. And then I have pi 9ths, which is here. So here's my entire angle. I'm looking for the reference angle, which is from the x-axis to my terminal ray, which I want is this angle here. And that angle just ends up happening being my pi 9ths angle. So this right here is your reference angle. Doesn't always happen that way. I suggest you draw a picture so you can visualize it. Let's try this again. 19 pi 6. I start out with 1 revolution. Oops, I keep doing pluses. 1 revolution is going to be 12 pi over 6. Why? Because this is equal to 2 pi. What do we have left over? I have 12 minus 19. I have 7 pi's left over. 7 pi is more than 6, so that means I can do 6 pi over 6. This is 1 pi. And what's left over? Pi over 6 to make that 7 pi to equal. When I add all this up, that's going to be equal to 19 pi over 6. Draw this out, sketch it out, see what we have. We have 1 full revolution. It's positive. We're going counterclockwise. We have half of a revolution because we have pi. Then we have pi 6, which is here. We're asking for the reference angle. Here's your x-intercept. Excuse me. Here's your x-axis. Here's your terminal ray. We want this angle here. So it just so happens that you've traveled 1 full revolution, half of a revolution, and then just a little bit more, which is that pi 6. And that's going to be your reference angle. Try this one here, 535 degrees. Now we're doing the same thing just with degrees, which is 360. 360 degrees is 1 full revolution. So 535 minus 360, 1 full revolution. That gives me 175 left over. Draw this out. It's positive, so we're going counterclockwise. So 1 full revolution. Then I need to go 175 more. 175 is really close to 180. This is 175. So my reference angle is my angle. So note this is one of these examples where it's not that little piece, you know, like kind of like what we had here. It's not like that. Our angle, reference angle, is from your x-axis to that little piece to your terminal ray. So it's that little piece. So if we have 360 here, then we have 100, then we have 175. What is this angle measure? In order to complete half of a revolution, that little angle measure has to be 5 degrees, and that's going to be your reference angle. 320, that's not enough to do 1 full revolution, so let's figure this out. Draw it out. I always encourage you to draw it out. This is 360, it is positive, we're going counterclockwise. This is 90 degrees, 180 degree, and 270 degrees. 1 full revolution would be 360. Half of a revolution would be 180. So if I do half of a revolution, let's see. I think we can do half of a revolution and then 1/4 because this is 270. I'm just wondering how close I am to 360. So here I am. It's somewhere here-ish. I need to know how close I am to 360. And I am about 40 degrees close to 360. So I'm about here-ish. But that kind of answering that question kind of gives me the reference angle, because the reference angle is from your x-axis to your terminal ray. What is this angle measure? Well, if my original angle is 320 degrees, I'm just going to need 40 more degrees to close up that full circle. That means that this right here is my reference angle, small, acute, and positive, from my x-axis to my terminal ray. All right, beautiful people. I don't know if we talked about coterminal angles in this video, but we will definitely do some more examples in class. Enjoy the rest of your day, and I will see you in the next video. Bye!